Dear students, welcome to the first semester of chemistry classes of Guampi University. Today we shall have a small discussion on the chemistry paper 1. In that we will going to have a discussion on chemistry paper 1, that is inorganic chemistry part I am going to discuss now. So in this session I am going to discuss about the unit 2 of chemistry syllabus, that is inorganic chemistry, and chapter 1, atomic structure. Now let us have an explanation for wave nature of electron, that in that de Broglie equation, Heisenberg's uncertainty principle, and Scrodinger equation. So there is no derivation of Scrodinger equation in your syllabus. And then we will see what is the significance of psi, that is wave function, and the psi square. Okay, the learning objectives of the present session is to know the meaning of wave nature, to know the Heisenberg's uncertainty principle, to know the de Broglie equation, and to know the Schrodinger wave equation. Before that, let us have a small introduction on the atomic structure in the historical perspective. And the outcome of the present session may be you can understand what exactly the wave nature of the particles, particularly electrons, and to understand the nature of atomic orbitals. If you look at the atomic structure, John Dalton in 1805, he gave a picture of the atomic structure, and he considered that all matter is composed of small particles called atoms. He visualized the atom as a hard solid individual particle, and which is not capable of subdivision. That means the atom is a solid object, it cannot be divided or broken. But at the end of 19th century, because of so many experimental evidences, it has been shown that the atom is not a undividable particle, but it can be divided into smaller particles called subatomic particles. These subatomic particles are called fundamental particles, and now the number of particles are very large. But for us, the important fundamental particles are proton, neutron, and electrons. And it is very interesting to see how fundamental particles go to make the internal structure of the atom. If you look at the history, the evolution of atomic structure by several scientists based on their discoveries. Earlier, John Dalton in 1805, he proposed that atom is a solid, undividable object, but in 1896, J.J. Thomson, after the discovery of electron, he shown that the atom can be divided. And later in 1909, Rutherford proposed another model for atom, and in 1913, Moseley he gave the atomic number, and in 1913, one of the very important discoveries, that is Bohr atomic model. In 1921, Bohr-Bury scheme of electronic arrangement was proposed, and in 1932, Chadwick's discovery of neutron. So if you look at this picture, it shows the evolution of the model for the atom. In 1805, here this shows atom is a solid matter. It cannot be divided further according to John Dalton. But If you come to see the Thomson model, it consists of positive and negative charges embedded in the whole mass of the atom. Later in 1909, Rutherford he proposed a model to show that the positive part of the atom is at the center and the electrons are revolving around the nucleus. But he did not give a fixed path for the movement of electrons. Later, his student Niels Bohr in 1913 he disproved the Rutherford model because, according to Rutherford, nucleus is at the center and the whole mass is at the center and electrons are revolving around the nucleus in a spherical path. Okay, so when the electron is revolving around the nucleus, what happens is any moving object, any charged moving object, it loses energy, and ultimately electron is a charged particle. As it moves around the nucleus, obviously what happens, it loses its energy and it must fall into nucleus and the atom must collapse. That is what Niels Bohr said about the Rutherford model. So Niels Bohr proposed another model where he showed that the electrons are revolving around the nucleus but in a fixed path called as orbits. Okay, and until and unless the electron is revolving in that orbit, its energy does not alter. So therefore, he said that the electron which is revolving around the nucleus is moving in a fixed circular or spherical path and the energy does not alter until and unless it moves to the higher energy level or it comes back to the lower energy level. So therefore, he said that the electronic energy or overall energy is quantized. Okay, he has given a model where he showed that the energy of the electron does not alter until and unless they are moving in the same path or same orbit. Okay, later in 1926, Scrodinger gave another model called as electron cloud model. Okay, he given the probability of finding the electron in a definite space around the nucleus. These are some of the models for the atomic structure given by several scientists, and it is the evolution of model for the atom or atomic structure. Okay, now let us see what is the wave nature of the electron. Bohr theory of atom, he said that the electrons are revolving around the nucleus in a circular orbit and its energy will not alter until and unless it moves in the same orbit. Okay, in 1923, de Broglie suggested that electron, like the light, it has a dual character. Okay, dual character means it may be either particle or it may be a wave. Okay, de Broglie he derived an equation called as very famous de Broglie equation based on the Planck's quantum theory and Einstein's theory. The derivation of de Broglie equation to show that the particles like electrons have the both wave character as well as particle character by considering the Planck's energy equation for photon and Einstein's mass energy relationship. Okay, let us have a particle or a particle like an electron whose mass is m. According to the Planck's energy equation, E is equal to h nu, where h is the Planck's constant and nu is a frequency. by the Einstein's energy mass relationship, E is equal to mc square. Now if you consider equation 1, that is E is equal to h nu and E is equal to mc square, if you equate these two, you will get h nu is equal to mc square. Alright, now it is very simple to simplify this equation. Nu, okay, nu is frequency, that is c divided by lambda. Okay, h nu becomes hc divided by lambda, that is equal to mc square. Now what is lambda? Lambda is equal to hc divided by mc square. Now c gets cancels, so you will have lambda is equal to h divided by mc. Okay, this is for the particle moving with the velocity of light. Okay, c is the velocity of light. The product hmc is called as momentum. All right, now if you can have the momentum of particle in motion is inversely proportional to the wavelength, right? The wavelength lambda associated with a moving particle is called de Broglie wavelength. All right, now if you look at this equation, that is lambda is equal to h divided by mc, this is the de Broglie equation for a particle like electron moving with the speed of light. Now if you consider a particle which is having a specific velocity v, the same equation, that is lambda is equal to h divided by mc, can be written as lambda is equal to h divided by m into v. Okay, this is the de Broglie equation for a particle like electron with a mass m moving with a velocity v. Then you will have lambda is equal to h divided by m into v. This is the de Broglie equation for the electron. Now if you look at this equation, you can see that it will have two terms. One is lambda, that is wavelength. Another term is the mass m. Now what you can say? You can say that the electron will have the dual character of both wave, because it is having a wavelength lambda, and it also behaves as a particle because it has a mass m. All right, so therefore electron can have both a wave character because of its wavelength and a particle character because of mass m. So therefore, according to de Broglie equation, lambda is equal to h divided by m into v. Okay, hope dear students you must understand here that according to de Broglie equation, the electron or any particle will have both wave character as well as particle character. The wave character depends upon the mass. Okay, smaller the mass, greater is the wave character. Okay, for example, if you consider an electron, it is very small object. Its mass is very less, hence it must have a larger wave character. Similarly, if you take a large object like a big rock, it is also having a wave character, but its mass is large, hence its wave character is less. Okay, hope you understood the derivation of de Broglie equation. Okay, now let us move on to another important principle, that is called as Heisenberg's uncertainty principle. It is very important after understanding the dual character of matter. According to Heisenberg's uncertainty principle, it is impossible to determine both position and momentum of the particle precisely and simultaneously. What is that? It is impossible to determine the position and momentum of a particle precisely or accurately and simultaneously. Okay, so when you determine the position, say for example, if a particle has a displacement of delta x, that is position delta x, and its momentum, say delta p, change in momentum is delta p, change in position is delta x. Now if you have the product of the delta x and delta p, then it will be equal to or greater than h divided by 4 pi. That means when you determine its position, then its momentum will have a difference of h divided by 4 pi. Or if you determine the position precisely, momentum precisely, then the position will have an error of at least h divided by 4 pi. So therefore you cannot determine the position and the momentum simultaneously and precisely. Okay, so from this equation it is clear that delta x is very small, then delta p would be large, and vice versa. Or in other words, so when you determine delta p, delta x will have an error of h divided by 4 pi, or delta x varies at least by h over 4 pi. Or when you determine delta x, delta p will vary from its exact value by at least h divided by 4 pi. So therefore you cannot determine the position delta x and momentum delta p simultaneously and precisely. This is the Heisenberg's uncertainty principle. Okay, so let us have a small calculation on Heisenberg's de Broglie equation. So calculate the de Broglie wavelength for a moving bullet of mass 0.2 kg and velocity 300 meter per second. H is given to be 6.627 into 10 to the power minus 34 joule second. Now, according to de Broglie equation, lambda is equal to h divided by 4 pi. When you substitute h is equal to 6.627 into 10 to the power minus 34 and divided by m is 0.2 into 10 to the power minus 3, or you can directly write as 10 to the 0.2 and into what is v, velocity, that is 300 meter per second. So the answer is 1.104 into 10 to the power minus 34 meters. The wavelength is like this. Similarly, you can calculate either lambda, or you can calculate m, or you can calculate v if you are given with the remaining parameters. Okay. Now let us move on to another important equation, that is called as Scrodinger wave equation. Okay. Now, to describe the behavior of wave function associated with the atomic particle, Scrodinger gave a mathematical equation known as Scrodinger equation, and he considered a very important term called as wave function. Wave function is very similar to the amplitude in the classical mechanics. So it describes completely the particle. Okay, according to Scrodinger equation, it is given by dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into E minus V into psi is equal to 0, where E is the total energy and V is the potential energy, m is the mass of the particle, h is Planck's constant, psi is the wave function. Okay, you can write the same equation in another way, that is del square psi plus 8 pi square m by h square into E minus V into psi is equal to 0. As there is no derivation in your syllabus, we are directly writing the Scrodinger equation, where del square is called as Laplacian operator. It is given by dou square by dou x square plus dou square by dou y square plus dou square by dou z square. for a three-dimensional moment. Okay. Now, what is the significance of psi? Psi means wave function. Okay. Psi is nothing but an important factor in the classical mechanics called as amplitude. Okay. There is no other significance other than the amplitude. However, the square of the wave function psi square is an important term called as probability of finding the particle of a given energy in a given region around the nucleus. So what is psi? Psi is amplitude factor, and psi square is a probability of finding the electron of a given energy in the given region around the nucleus. Okay. So differences between orbit and orbital. What is an orbit? It is a definite circular path around the nucleus in which electron is supposed to revolve. What is an orbital? It is a three-dimensional region around the nucleus in which there is a maximum probability of finding electron. What is orbit? It is a circular, it has circular shape, but orbital can have a definite three-dimensional shape. An orbit can contain maximum of 2n square electrons, where n is the order of orbit. An orbital can have maximum of 2 electrons. At the same time, the position and momentum of electron can be calculated in the orbit. But in the orbital, at the same time, the position and momentum of the electron cannot be calculated. These are the differences between orbit and orbital. Okay. What is atomic orbital then? It is a spatial distribution of probable electron density in an energy level around the nucleus. Okay. What is that? It is a spatial distribution of probable electron density in an energy level around the nucleus is called as an orbital. In the orbital, there will be maximum probability of finding the electron. Atomic orbital is a three-dimensional region, as we said earlier, right? Where there is maximum probability of finding the electrons. Okay. So when you look at the multiple choice questions, let us have few multiple choice questions here. What is de Broglie equation? You have these four options, and the correct answer is h divided by mc. Okay. So it is impossible to determine accurately the position and momentum of particles simultaneously and precisely is called dash. So it is called as Heisenberg's uncertainty principle. The option is C. Okay. Next is the maximum number of electrons present in an orbital is obviously 2. Okay. You go through these textbooks, please. That is Principle of Inorganic Chemistry by Puri, Sharma and Kalia. Modern Inorganic Chemistry by R.D. Madan. So good luck, dear students. We will meet in the next session where we will have a discussion on the continued part of your inorganic chemistry syllabus. Okay. Thank you very much.